Hello, okay, hello, Vicky, hello, Ariel, hello, Vicky, hello, Kalola, hello, Nayoon, hello, Samantha, I'm doing the romper room thing here, hello, Alexandra, thank you, hello, Andreas, hello, okay, hello, who else, yeah, I think that's everybody, right, Carolina is about to be, hello, all right, we are gonna do a slightly new, I've come up with a way. I think I've been slowly killing this class. I mean, in the bad way, like destroy. But I want to try to resurrect it. I know 2.5 hours is so long. I think I found a way in the last couple of periods to make this a little bit more fun or something for everybody. Because some people have been participating a lot, and it really helps whenever they do. And then I've been like extolling their virtues, but then like leaving everybody else cold. It doesn't like do anything for anybody else. All right, here's as soon as I confirm some things from you guys, like as soon as I make sure I'm right in what I think about where you were yesterday in lab, well, we're going to start a slightly new approach. I'm going to start trying to shift any of the points that I want to give and will continue to give to you all for doing any kind of homework, right? Like all the homework are supposed to be points that just get added to your average, that where you're supposed to be rewarded whether you're right or wrong for whatever you do in the homework. And you're supposed to be rewarded, at least as far as I'm concerned, even if you're not perfectly on time or something like that. I want to start, and that's still all true. Whatever philosophy we have on homework is still all completely true. But because this is like Zoom classes and all that, I want to start shifting a lot more of those points, like the grade points, stuff that you can get, or the opportunities you can get to class participation more directly to like what we do in class. So you're going to see so you might have seen that I put 2 new assignments in the Google Classroom, both of which are due next week. They might look crazy. Well, first of all, let me confirm. Do you guys see that there's 2 new? They're very easy. I mean, but they're 2 new 50-point assignments. One is called A Game, Take One, and the other one is called A Game for Right or for Wrong. Can anybody? You see them? Thank you, Samantha. Okay. Interestingly, and thank you. All right. So now, and thank you. So, like for example, what?
Sorry. You said they're due next week?
Yes. Did I put the wrong?
No, because I thought we didn't have class next week.
I'm sorry. Maybe that's even true. Well, hold on. First of all, thank you. If that's true, then I apologize. And no, then I mean the next time we have class. But what is next week? Next week we don't have class. What's next Wednesday?
I thought it was a Monday schedule. I might be wrong.
I'm sure you're right. I never know. No, I'm sure if you say so, you're probably right. And then and good for all of us. Okay, I didn't even realize that. So then I'll change it in the middle of today's class. I'll even change it then so it's 2 weeks from now. I don't mean anything weird. I mean the next time we're meeting. And you're even going to find when I explain these assignments, you're going to end up, you in particular, in fact, you, if that was just Carolina. Do I say Carolina or Carolina? I forget.
Carolina.
Okay, Carolina. So specifically, Carolina is going to find that the assignments are even easier than she thinks, and she's probably going to be done with them tonight. Because here's how the assignment works. They're really more like they're like point portals for a game more than they really are like any kind of tricky assignment. What's going to happen is once we get rolling in class today, or for the period of time we do this, I'm going to put a question like on my board, like I often do, like we're often working on these questions, right, to solve problems, whether they're practice or from the homework or from the lab, whatever. I'm going to put a problem, and it won't be deliberate. It will not be like deliberately tricky or something, but it'll be deliberately like important to what we're doing. And I'm going to say from that moment, it's up to you guys to solve. I'm not going to put you in breakout rooms because I think that has mixed effects. We're going to all stay as a class, but I'm going to say this. Once I give you a question or problem, first of all, I'm going to say anybody who says anything about the problem at all, like, or puts anything in the public chat, like, and it could be like, I don't understand this part of the question, or it could be, I think this is the answer. or I like anything. If anybody puts anything that contributes to our help to get that problem, then they've contributed. Okay. And what's going to happen? And first of all, that'll help. I'm sorry, someone's here. I'm letting them in. So you guys are going to try to solve the problem. And I'm not going to say much until you get to the right answer, at which point I will say, oh, yes, you got it. Great. And now we're going to move on. So some of my problems, if they're easy, like someone might get the right answer right away, and then I'll say, yes, that's the right answer. That's awesome. But until someone gets the right answer, you guys are going to say or do whatever you want or need in order to get closer to the right answer. I might or might not give hints. I might or might not say much, but anybody that says anything in that conversation is just going to try to remember what they said, or not even, and take 2 minutes later on, like during the period or after the period, to just jot down on a piece of paper, like I'm Carolina and I said that thing about square root of 2 or whatever. I'm being literal to all of you now. Like, say Carolina says something about square root of 2. Like she says, oh, I'm getting the square root of 2. Like whether she thinks it's the answer or not, she might even just think it's a step, or she might have a question like, wait, can you even get a square root for like a physics problem? Whatever Carolina says, I even asked you, and I'm still saying it wrong. Right, say your name one more time. I'm sorry. I even asked you, and I'm still.
It's okay. Carolina.
Oh, okay,
Carolina.
Carolina.
You said it right.
Oh, okay. So I don't know why I'm double. All right. So Carolina, and by the way, literally at this point in this class already, Carolina has earned 100 points. You'll see why in a second. But she would literally, if she said anything at all, she would just remember, jot it on a piece of paper, like I said that thing about the square root of 2 when on question 1, right? And she'll just write that down, take a picture of it, make a PDF, and submit it to that assignment portal, the game Take One. And that's just as verification or reminder of the one contribution she made to the discussion. And she'll automatically get the full 50 points for that, like a 50 homework credit points, which do matter in your grade in the end and do help. Now, if someone didn't do anything, they just like wouldn't get any points. No one's going to be punished or whatnot. But that's if she says anything at all. Now, again, we're going to do this, like anybody who says anything at all, even if you don't trust that, like, I don't remember, like, even if you're worried that I might not remember that you said something, that's why you're writing it on a piece of paper and you're putting it in, and boom, that's going to be 50 points. Also, of course, anybody who says anything, I mean, the joke is I will remember, like, and it will be a way of you getting to know me better or me getting to know you. And it's just like, of course, helps your grade anyway. But I want to go further and make this clearer to everybody. And we're going to do this. Like, I'm going to ask you guys a question, and we're not going to stop on the question until you guys get a right answer, whether it's easy or hard. And again, maybe if it's super easy, you'll get the answer right away. Great. But either way, anybody who says anything will get 50 points, 50 homework points. But plus, in addition to that, if anybody says anything, like, and that includes if you ask a question, that includes if you say, Nicola just said something, could she repeat it? It includes, by the way, half the time, like here when I'm yammering along and then I stop and I say to everybody, hold on, did you all get that thing in the Google stream? Or can you all hear me now? Anybody who's like writing yes in the chat, like Kilola, Anastasia, Alexandra, and like Vicky, like tons of times last time, any of those people, even if they didn't say anything from here on today, and of course, I hope that's not true, but literally for homework, like I'm saying, literally, Kilola could write down on a piece of paper now, I'm the one that said yes when you asked, did everybody get this thing in their Google stream? Or when you asked, can everybody hear me? The fact that she said yes, as long as she writes that down, that's 50 points. Like, and again, not a joke, because it's that actually useful to all of us for everybody to participate. But now I'm going a step further. That's if you say anything. If we're discussing the problem, the physics problem at hand, and anybody says anything or writes in the public chat anything to which I respond, oh, that's the right answer, or oh, that's right, or to which I respond, oh, that's wrong. And I'll hopefully be like slightly more polite about that or something. But like anybody who says anything to which I actually say that's right or that's wrong, if, in other words, if it was risky enough, if it was gutsy enough, if it was precise enough to be like a stab at an answer, if someone says like, I think the answer is this, or even if they say like, I really think you should use this equation. If I go, well, okay, really good point, but actually, no, you shouldn't use that equation. If I even say that's wrong, then that counts as an extra 50 points, meaning this is assignment 2. Like the reason there's the second portal that I put in the Google stream, hopefully you saw, the one that's called a game for right or for wrong or for true or for false or something like that. I'm literally saying now, if you ever say anything to which I respond, that's wrong or that's right, either one, then you can submit that into the second portal and get another 50 points. And just to be super clear about this, I'm saying you can double dip. I'm saying once you say something that I say that that's right or that's wrong to, well, first of all, that counts as you saying anything. So you can put it in the first assignment portal for 50 points. But then second of all, it's specifically like it's a subset, it's special. If you actually said something that was gutsy enough that it could possibly have been wrong, and like even if I do say it's wrong, then you can take that same comment, the same comment, and write on a separate piece of paper. I'm counting the same comment also for like assignment portal number 2, because like I said it was the square root of 2 and you Yaverbaum said it was wrong, or you Yaverbaum said it was right. I want to emphasize this to everybody. I want to make, this is the rules that we're going to play by, or we're going to try. Like, obviously, if it's a disaster, I'm only doing this because I think it's going to benefit everybody. Of course, this is not meant to be a trick. We are going to try it. And if it works, we're going to do more and more of it. But the main point I'm trying to get across to everybody is you're going to start getting points for just saying freaking anything, other than something offensive. And you're going to get an equal amount of points for saying something wrong as you would if it's right. Because I really want to drum into everybody that what's important for moving forward is making claims that could be wrong or right. Like it takes so much guts to try in front of other people to do something that might end up being wrong. I think it holds us all back enormously, especially me, or in particular me. So you will get rewarded equally if it's wrong or right, but you'll get rewarded even more than just saying anything if it's actually the kind of thing that could be wrong or right. That's what I'm trying. So it hasn't started yet. Well, it sort of has. I mean, it has started. Anybody who said anything thus far today already can submit that, like whatever they want for any, and that's all you have to do for this homework, for this 50 points. You just write on a piece of paper, like I said that thing on Wednesday, blah, and you'll get the 50 points. In a moment, we're going to start it more officially with the actual physics question I want to do here. But first of all, does that make, do you get what I'm saying, you guys? Like, do you get the idea of how this is going to work? Like put electronic hands. Yes, thank you. And that would be 50 points right there. If she hasn't, thank you. So like Anastasia and okay. I like the exclamation point. Yes, question, yes.
I'm a little bit confused. So you said that like whatever we say in this class, so next time we have to write down on the paper and take a picture and like add it on the Google Classroom?
Yeah, but you don't even have to wait till next time. I'm saying like even the comment you're saying right now, like right now you're saying, I'm a little unclear about the rules. How does this work? And that was a comment you made. So if you write that on a piece of paper, if you just remind me, I said today in class, I was confused about how the rules work, and you take a picture and put it in for the assignment, the assignment that I said is due next week called a game, like the assignment you just found in Google Classroom. Yeah, if you put it there, yes, I'm saying you'll get full 50 points as though you solved a million physics problems. I'll give you 50 points. In other words, I'm trying to reward anybody who says things in class. And
okay.
So yes, that's yes.
Thank you so much.
Okay, thank you. All right, and so but the flip side to everybody, it sounds like people get it, which is good. And we're going to try to use this as our way of moving along through the material. This way, if I ask a question and it's really easy for you guys, you'll get it fast and it'll be clear to me and we'll be able to move on. But if it's hard, I'll see that, whatever. And hopefully we'll be less worried about taking risks. So we're going to start in a second, but now let me just make sure of one thing. I mean, I think I know what I'm doing here, but could someone, and this can count for points if you want, but could someone just briefly confirm or remind me, in lab yesterday, you did a new motion, yes or no? Or does someone want to briefly summarize what you think you did in lab yesterday?
We looked at, so we received 3 videos of 3 moving objects. Then we had to use, I forgot the program name, Logger.
Oh, Logger Pro.
Logger Pro, yeah.
Okay. Okay.
We put the video up and we record the graph that it made for us. And with that, we determine what equation it goes for.
Great. That's very helpful. Okay, thank you. I was hoping that you were going to say that's very helpful. That's very clear. Thank you, Vicky. And that's totally 50 points. That counts as 50 points, definitely. We're in the chat. Position versus time graphs on Logger Pro. Right. Okay. Yes. And thank you, Alexandra. This makes sense. This is what I thought. This is what I was hoping, just making sure, because I know we missed class last week. So now, is there anybody, did an equation come out of that? Did a motion? and I'm not doing this to quiz people, I'm just making, so just make sure I'm aligned. Does anybody have an equation that came out of that? Or are you still working on that at home? Like, is there, like, what is motion for? I guess I'm asking if anybody,
I think it has to do with sine or cosine.
I think,
If I'm not mistaken.
okay. Like something like,
Yes, it was cosine.
Cosine. Okay, yeah, okay. Then cosine.
something like, tell me, did it look something like this, or something like this, or something like this?
The second one, the x equals a cosine
Oh, okay.
WT.
And literally that, okay, that's your motion for that. Okay, and other people have confirmed that or agree, like that's this one here is what you're.
Yeah, that was it.
Great. Okay. Okay. Good to know. That's all right. Now I know where you are. That makes sense. That's cool. So I'm going to ask, so based on that, I'm going to ask a question. Right? Again, I'm going to ask a series of questions, right? Like they're not meant to be tricks. You might think they're easy or hard. We're trying to find out where we are with this. And as long as we progress, we progress. So forgive me, but just take them at face value. So here it comes. Okay. Okay, so I'm going to explain this. Yeah, so please copy this down. I'll try. First, I'll read it out loud if it helps the handwriting, and I'll try to draw a diagram. But this is the setup, and I know, and I believe me, if you're getting sick of the mass on a spring discussion, I mean, in a way, so am I. I do sympathize that it's a lot of. We keep coming back to the mass on a spring, but it does. But it is a super important system. Anyway, picture a mass on a spring that's going back and forth and back and forth and back and forth. It starts from the mass, and we're watching it go back and forth at a constant angular frequency known as omega equals pi radians per second. You might be intimidated by the pi. If you are, you could just say equals approximately 3.14 radians per second. Excuse me, you could say like 3.14 radians per second, or you could even say 3 radians per second if it makes it easier to picture. But so don't be intimidated by the pi, but I am saying at an angular frequency of like pi radians per second, so that's a given right there. That's like a known. One other given that I'm giving, the other one is that this mass that's going back and forth on a spring is initially at 2 meters from equilibrium. That's the other given, meaning either like when you start this whole experiment, it's right there, 2 meters stretched away from equilibrium, or meaning more realistically, this thing's been going back and forth for a long time, and you walk in while it's doing this, and you start your stopwatch right when, like, you start the experiment, you start collecting data right when this thing happens to be 2 meters, I'll even call it positive 2 meters, like 2 meters on the, say, the right-hand side, if you like, of equilibrium. That's where it is when the whole thing starts, and it goes back and forth at pi radians per second. What I want to know is, where will you find the mass? Like how many meters from equilibrium, or centimeters or whatever, and on what side, the positive side or the negative side? I want to know what's the position at t equals 1 second. I mean, this is kind of like the very first homework, sort of, but it's now, I'm basing this on, I'm assuming that you would use motion 4 or your most recent stuff in order to get this. This is my question. There will be more questions. There'll be more questions based on this setup. So maybe I'll draw the setup in a second on the next page, but this is the question. And again, what I'm saying is, like, once it's clear that this is the question, you guys just take it. And the minute I hear a right answer, I will let you know that it's the right answer. But until that time, we'll just discuss it until we get there. So this is the question. The question, where is, like, what is X? So you're solving for X, if you like. Where is X at t equals 1? That is the question. So anybody can do anything they want. But I'll say, I'm going to just, on the next page, I'm just going to literally put a picture. I'm going to rewrite the same exact thing. So don't worry if you're, I'm going to write the same thing, but just smaller with a picture so you can see it more clearly. But this is the problem. So take it away, say whatever you want publicly, or yeah. So again, if anybody, when anybody, no one has to wait for anybody. If anybody has a thought at any time, whether they think it's a final answer or a step, it's up to you. You could close this shop now by just getting in it. But you guys, I'm not waiting. You're not waiting for me, and I'm not waiting for you. Well, I am waiting for you. You guys just say whatever you think, and I will tell you once you have a right answer. But until that time, I'm not going to say anything. That's the deal. But anybody who does say anything gets points, whether it's right or wrong. And you can totally use the public chat, absolutely. But the private chat, you can use it, but I won't give points for that because that's a whole different thing. And it's not meant to be a trick, and it definitely has to do with motion 4, or whatever you all just told me was motion 4. I think is all you need to know too.
So I just want to be clear, the 2 meters for X initially, we use that to determine what A is?
Yes, yes, that would be counted as right, and that would be counted as 50 points. And yet, and we're not, and that's totally awesome. And I want to say even less than I'm saying now, but just to get this, but yes, she's totally right. That doesn't mean we're done, right? We still have to get it. But what Vicky is saying is like, can we use that initial position 2 for our A? And absolutely, yes, A is 2. And if you're thinking the same equation I'm thinking, then you're basically just about there at a final answer, like whether it's Vicky or anybody else. And then we could. So we know, in other words, and guys, just to be clear again, I'm saying it's motion 4. I'm saying we will go on once we get a right answer. I'm saying these are the facts. It's not meant to be a trick, but I won't go on until someone else says the right answer. Thank you, Ariel. I was yes. Okay, Ariel in the chat says it. And thank you, Vicky, definitely for getting us off the ground without a doubt. But Ariel, yeah, I was about to have a heart attack, actually. No, I wasn't. But yes. Okay, first of all, her answer is right. So again, just to be clear, like both Vicky and Ariel, they would for homework 1 of the 2 homeworks I just put out today. In the first one, they would just write on a piece of paper like, I'm the one that said, can we use A for 2 or whatever. And Ariel would say, I'm the one that said X equals -2. They would also fill out that exact same thing for the second homework because both of them had the guts to say something so specific as to merit either truth or falsity. Like I would be just as happy if Ariel actually had said -3, even though it was wrong. It'd be so specific I could say something. But in fact, she got it right, which makes me even happier, of course. So she and now Vicky, I'm saying they're each going to get, as though they just did 2 homework assignments. They're going to get the full credit of 2 for doing that. And I do want to emphasize that. And everybody can do it, and everybody should do it, and everybody's grades will go high. But of course, if only some people do it, then only those grades will go like that. But yes. Ariel, can you explain? I don't want to punish you for good, but can you explain to the world how you got that -2? And you could do it in the chat if you'd prefer, or not at all if you prefer to.
I actually just plugged in what A was and what C was.
Yeah, you plugged into, yes, absolutely. And you plugged into what? Into what?
I plugged for A, I plugged into cosine. I just left that the same. And then for pi rad over seconds, I just canceled out seconds and timed it by 1 and just got 2
Awesome.
when I put in.
But right, no, awesome. But I mean, what equation, just to make it clear to everybody else who didn't, like what equation are you plugging into? What equation are you talking about?
X equals A cosine the angular frequency T. See?
Yes. Okay. Just want to make absolutely clear. Yes. So look, none of this, I don't mean this to be tricky hard or whatever, but I also don't want to drag around everybody on the easy stuff. So like, if this is easy for everybody, we'll go faster. But yes, I mean, it's true. What Vicky and Ariel are doing is just taking the motion number 4, and they're plugging in. Hopefully I'm not giving them a heart attack with the difficulty of it, but that's all I'm asking everybody to do. But again, if everybody could, but if there's any question, they should ask it. But yeah, Vicky's saying, okay, if this is the case, and I mean, Ariel is saying that's the case, and Vicky's saying this is the case, and I'm saying this is the case. So they're solving. They're just literally we're just seeing what this equation means. So they're going like this. Okay, it's not that's exactly right, and that's all I'm getting so far. But and you do have to. I mean, you might know the cosine of pi in your head, or you might type it into a calculator. Either one is fine. Well, right now, either one is fine. But I like how she said, how Ariel said the seconds canceled, or she said something about yeah, she did say radians per second times seconds, and they canceled. Totally true. And also notice, if you put this in your calculator, if you use calculator, this will only work if you're in radian mode. This is definitely assuming radians. That pi number was pi radians per second. It's possible to not use your calculator for something like this as you're getting used to it, like pi radians per second. When I say, I mean, to a lot of people, if I say, if I say omega equals pi radians per second, that looks like a lot of weirdness. It doesn't look like numbers or anything real. Omega equals pi. But what it's saying is, it's that this oscillator is oscillating at a rate of pi radians per second, means half a cycle per second, right? Always remember there's 2 pi radians to every cycle. So if this thing is doing pi radians per second, that's fancy language for saying it's doing a cycle, a half a cycle per second. What is a cycle? A cycle is round trip, there and back. So this thing, after 1 second, had only gone there because right, because it's going at a rate of 1/2 a cycle every second. So every second it goes a half a cycle. In the first second it goes a half a cycle, just there, from all the way out here at +2 to there, the other endpoint at -2. That's what's happening logically. All right, but good. So some people just got points. Hopefully everybody. I'm going to go on to the next question now. Like just a slightly. We're just going to stay with the same concept here. So bear with me. But good job. We're already making more progress, I think, than maybe. Okay, here's the question 2, based on the first question, very similar, but slightly different, of course. So picture the same system, a mass on a spring, like we've been picturing. I'm getting sick of it too. A mass on a spring. Again, picture that that mass is initially held at 2 meters away from equilibrium, like 2 meters on the right side of equilibrium, if you like. So same exact deal as before, but this time we know something. Oh, this time I should say it's a slightly different spring. It's either a stronger spring or a weaker spring, just to be clear. But this time, just to be clear. Okay, so this time we do the same setup, but it's a slightly different spring now. I don't know if it's stronger or weaker, but in other words, a spring with a different K now. Now, again, I didn't even know the K of the spring before, and I still don't know, and I still don't care. I'm not trying to confuse anybody, but I'm just trying to say now we have a spring that's slightly different. So this time, it's going back and forth and back and forth. Instead of knowing its angular frequency is pi radians per second, we actually know something more direct from the lab. Let's say this time we know that one cycle takes 8 seconds. Okay, before, in other words, before the known was omega equals pi. This time I'm saying, imagine that the known, the given here from our measurements is that the period, capital T, okay, the period, capital T is 8 seconds. That's the given this time. Now, given that, I want to ask the same question as before. At lowercase t equals 1 second, what's x? So let me repeat. I'm asking the same question as before. Where is this thing at t equals 1? At 1 second, where is this thing? I'm assuming the same kind of system. Any physics you understood from a question ago will apply here. But I'm just saying now and again, like to be really direct, like Vicky's thing before of, can we say that A equals 2? The answer then was yes, and the answer here still is yes. I mean, again, to try to distill matters here, A is still 2, but the big difference now is instead of knowing that omega is pi, I'm telling you this time, capital T, period of one cycle is 8 seconds. Given that, what's x at t equals 1? And so again, I turn it to any or all of you. And of course, if at any given moment, if two people try to say something, like someone who said something a lot and someone who hasn't, of course, I know that the people who have said stuff will defer to the new person so that they can get points too. But after a while, if there's like no one's talking and no new people are saying anything, of course, people that say stuff a lot could still save the day and still say, we're just trying to distribute the goods here. But of course, whoever can get us there should help get us there. So this is the question. Again, Q2, this is the question. I'm going to shut up. And if I turn off my video from time to time, it's so that I stop freaking myself out, just like looking in the electronic mirror. But I'm here and I'm just watching the chat and watching to see if anybody says anything. And again, if you get the answer right away, then we move on to better stuff. But we're just going to wait until we get an answer.
Did you say that omega is 8 seconds?
Oh, sorry. Thank you. Great question. By the way, oh, wow. And the chat went so fast. Oh my God. Wait, good question. And by the way, that question itself would get 50 points if you didn't say anything else. But no, I'm not saying omega equals 8. This time I'm giving a different fact. I'm saying that capital T, the period of one cycle equals 8 seconds. So you're going to have to use some other equations or some other knowledge to figure out how to get to omega from there. So I'm not giving you omega this time. I'm giving you just capital T. But that's a good question. But now I'm looking at the chat. Someone might have already gotten it. Hold on. Oh, wow. 1 second. Great. Totally agree. Okay. And by the way, there's 2 things in the chat. Maybe I missed these before. My bad. I don't know if they're from before or now, but I totally agree with Vicky who says motion 4. Like this is, again, definitely yes. Motion 4, x equals a cosine omega t. Totally the way to do this. Only this time you don't know omega yet. You're going to figure out. Then Kilola did something smart and said x equals -16. And I could see there's something very smart about that. She's definitely on the right track. She's doing something helpful, which again would be 50 points. But I don't actually think it's the right answer. And I'm not going to say why or anything until I'm forced to. But so I still think there's some work, but I am watching the chat and I am watching the world. I don't think that's the right answer. the reason I might say why well, I mean, I know the right answers. Okay. So watching the chat's like excited. This is like watching a TV show that isn't bad. You're right. Whoa, yes. Okay. So first of all, like what Anastasia is asking, and again, if Anastasia were to say nothing else this whole class, she could write down her thing about would the equation be t equals time cycles. I just want to emphasize again, if she just copies that on a piece of paper and puts it in as a PDF for like today, that will be 50 points right there. Now, what I want to say about it is it's true that yeah, like the t that I gave you, the 8, is the amount of time per cycle. But as far as like relating that to anything else through equations, I will agree. I have to say is correct what Vicky R is, well, she's always Vicky R, what Vicky is saying to, like, yes, she's right. That's how you can get from the information I'm giving you to the omega that you need. I think it's also helpful of her. I think it's probable that she has the answer in her mind, and I actually appreciate that she hasn't totally said it yet. I think that actually is helpful to everybody. But yes, like whatever answer's in her mind is right, because the way she's doing it is right, if I may say. But even if it were wrong, it would be spiritually right. But yeah. So, but I'm still going to wait. I'm not trying to torture anybody, but I'm not going to say the right answer. And I think it would be good for anybody else to use her hints or whatever and try to get there. And now I get, okay.
Professor, I have a question.
Yes.
When do we know if we should use cosine in an equation?
Oh, well, very good question. In a way, well, that's a really good question. And that would be a 50-point question. All right, number one, I will say everything that we're doing right now, we are definitely using that cosine equation. Like everything I'm asking now, it is practice in using that cosine equation. It's just that what I'm trying to build here, so you're definitely using the cosine for every one of these questions, but as these questions get like harder and harder, and by the way, I am seeing the fast, exciting things are happening in the chat. I will get to it in a second. I see them, I can't. But you do have to use the cosine, but as these questions get thicker and thicker or harder and harder, you'll have to do other things before you get to the cosine or something. Like in the example of this one, you do want to use that cosine thing, but the cosine thing has an omega in it, and I didn't give you omega here. So you have to do some work first to get omega. But the answer is, to your question really is, any time we're talking about an oscillator, if we're talking about anything that harmonically oscillates, any object that goes back and forth, or any system, any variable, measurement that goes back and forth and back and forth and back and forth continuously and constantly, we use the cosine to answer questions about that, if that makes sense. But yeah, it's all about the cosine right now. Now, I'm looking at the chat. I'm going to hang on for a second. I will say too, see, and with the chat, I'm going to take a moment to go through it and also do something on a piece of paper. I will say, with the private chat, I totally understand why people are putting things in the private chat, but in a way, I'm kind of trying to encourage you guys. Like, I will literally give you, it tends to be the case that what people put in the private chat is like, is this the right answer? Because they're afraid, because it's bold and they're afraid it might be wrong if it's public. And I get that. So I don't want to, I'm not saying you can't do that, and I'm not chastising anybody, but I will give the 50 points, whether you're right or wrong, if it's in the public chat. I'm not going to do that if it's in the private chat, because it sort of defeats the purpose. I kind of want to keep the private chat for things like people that have like actual, like a private problem. Like I have to go right now, or like my arm is bleeding, or like I need an appointment with you to get a a graduate school recommendation or something. But like, if you have an answer and you're thinking something, I want to encourage you to feel comfortable to not just ask me. I will answer these, but I'm going to give the points for anything that goes public. And again, no, I'm going to give the points whether it's right or wrong. So there's really no reason to actually be secretive about it. And everybody, if all of you could see all these private chats, you would all feel a lot more comfortable not being private. That's the funny thing. If all of you could see what all of the rest of you write, and a lot of you do use them, and a lot, but it's generally because people are privately asking me if something is right or not. And I get why that is private, but it doesn't need to be, because we don't need to feel so bad about wrong answers. So, but I'm going to pause for a second. I'm going to figure out the right. I'm going to make sure my answer is right before I say it, and then I'm going to look at these. So hang on. But you can keep putting in whatever or saying whatever.
Hi, Professor. So quick question. The units for A, is it rads per meter?
Really good question. Really good question.
I mean, meters per rad, sorry.
For A, wow, that's really, for A, they are meters, and they're literally just meters. For A, I could see why you would think there'd be the rads under there. And sometimes that happens, but no, it's just meters, because A is just literally how far something is from the equilibrium position. Does that make sense? So wait, I'm looking in the, oh yeah. Wait, so what I'm gonna try to do, hold on one second. Okay. Wait, I'm just gonna take a second to. Hold on, I'm just looking still. I think. I'll get, how about wait, I'm looking. Okay, so I'm seeing all the ones in the public chat now. So Vicky R's hint is totally right. And I appreciate, and then, and she had the guts to carry it all the way through. I will say at this point, I don't think Vicky's final answer is the one that I get. I'll check again. I don't think so, but I definitely think the hints are right. And then I think, oh, and then Ariel, thank you for going public. Right. So now to cut the madness, the answer 1.41 is the answer I'm getting, and the answer that I do think is right. I'll write this down in a second. And I do think this question was slightly harder. It had more steps. It may be more confusing, but I do think the answer 1.41 or square root of 2 is right. I will say though, I got to be careful. It's since the units are really important and everybody's asking good questions about the units of the final answer will be meters. Like X does stand for where this thing is, and A, oh, Yeah, so please, I do want to, I'm realizing some things that are important about this. So everybody, please do copy this down. Then I'm going to go on the next page. I want to write a couple of notes about this, and then of course I'll solve it for you directly. But the answer, right? The answer is 1.41, but it's 1.41 meters. I want to show you that. Also, I want to talk a little bit about whether we should say 1.41 or square root of 2 or whatever. But first, please write this down. Remember, what I'm saying here is X stands for position. X does mean literally where something is. In this case, the mass on the spring, like where, if you had a ruler underneath the whole apparatus, if you had a number line underneath the whole apparatus, and you designate 0 to be the equilibrium position and everything on the left side of 0 to be negative numbers and everything on the right to be positives, like X is really where we find this thing relative to 0 measured in meters. Then X naught is also measured in meters. X naught is also a position. It's specifically the initial position, right? X naught is the position where this thing first was when the experiment started, like when t equals 0, which really means, more specifically, it's where this thing was when its velocity was nothing, when it was all the way at an endpoint, about stretched out, sitting there ready to go, or having slowed down all the way about to start speeding up the other direction. This is X and this is X naught. But then, and this all goes back to sort of the Vicky thing from before, that's X is in positions. X naught is, X is measured in meters. X naught is measured in meters. But also now, let's be clear, A, just before we go any further, I want to make clear, like, we have X is a variable. Where is this thing at any given time? X naught is a constant. It's the initial value of that variable. It's where the thing was initially at time equals 0. That's X naught. Then we have A. A stands for the maximum position that this place ever gets to, the maximum displacement from equilibrium. All of these things are measured in meters. All of them are related, but X is a variable. X naught and A are constants. X naught is initial position. A is maximum position. But for a harmonic oscillator, the whole point of a big point of a harmonic oscillator is that it conserves energy, and the initial equals the maximum. The initial and the maximum are one and the same. That's such like a sort of special property of them that we wrap the whole bundle together in one thing and call it the amplitude. In other words, that's why Vicky was right that, like, sometimes we call it X naught or sometimes we call it A. It's the same thing. The initial and the maximum place for an oscillator, either way, is called amplitude, and often we abbreviate it with A. Okay, but that's all those displacements are measured in meters. So now the situation we have here for the question we were just doing, right? This was the question, question 2, right? This was the question. And what we're saying is, yeah, we got to use this cosine thing again, but this time omega wasn't given. The rate at which it was going back and forth was not given. The period of one cycle was given. What Vicky was saying in the chat is, okay, you can convert, or this goes now to how to understand these equations from 2 weeks ago, from motion 3, that, oh yes, like angular frequency is how many radians per second something does. Why we would have, what is a radian? The important thing is that there's 2 pi radians per cycle. In other words, remember this, well, like she said in the chat, but sorry, sorry, I don't mean to do this. Sorry. What I mean to say, I'm going to do it in a second, but what I mean to say is, like the first thing is, if I tell you that this thing is going back and forth, and it takes 8 seconds to do a full cycle, the first thing is Vicky saying, well, yeah, if it takes 8 seconds to do a full cycle, if it takes 8 seconds to go there and back, that means it does 1/8 of a cycle every second, right? If it takes 8 seconds to do a full cycle, then when 1 second has elapsed, it's only traversed 1/8 of a cycle. It's standard frequency. And if its period is 8 seconds, then its standard frequency is 0.125 cycles per second, and remember, 1 cycle per second is called a hertz. So far what we're saying is, oh, this thing, if we measured in the lab that it takes 8 seconds to do a cycle, then we're saying, okay, its frequency is 0.125 hertz. So what? Well, then, what then Vicky's saying is, okay, so it does 1/8 of a cycle per second, 1/8 of a cycle per second. Oh, well, there's 2 pi radians per cycle, so we can convert that to how many radians per second it does, which is what we need. In other words, right? So far, now again, I'm trying to make it as clear as I can. I'm not saying everybody would do every single one of these steps in their head or whatever, but we started with the same kind of problem. We know we have to use a cosine omega t, but we weren't given omega, so we go through a couple of steps to convert our capital T into an omega. We now have an angular frequency, 5/4 radians per second. So this is where people, a number of people, Ariel and so forth. Oh, no,
Where did you get the 4 from?
Oh, sorry. Oh, because good question. Who asked that? Was that?
That was me.
Okay, thank you. Samantha. Where I got the 4 from is because I have 0.250 times pi written in the second last line. So if I back up and look at it, that's like saying 0.25 times pi times 0.25. That's the same thing as, so pi times 1/4 is the same thing as pi divided by 4. I guess I'm saying, wait, hold on. I'm saying,
Okay, thank you.
oh, okay, cool. And good question, thank you. And weirdly, I feel like I get questions like that more when we do things this way. That's a great question. Okay, but so we have this now, and so then we're just about there. Now we can go back and do the thing we wanted to do, as long as we don't forget what the question is, and I can turn back if anybody wants. But so now we have this. And now this is where, okay, we're almost done. This is where you could plug this into a calculator and that'd be fine. And you would get a right answer and you might have to chop up digits or whatever. Or you can back up and look at it like pi over 4. I mean, well, then they have 2 choices. Here, hold on a second. Okay, this I know I already said, but now 2. So if you're going to plug in calculator, make sure you're ready to know. But 2, you could, and it wouldn't be a bad idea in your mind or on paper or for practice or from practice, you might want to convert that to degrees in your mind. Like, you might say, oh, pi over 4, wait, that's like one of those angles that I like actually could maybe know, which is true. Pi over 4, like pi, remember 2 pi is all the way around 360. So pi is halfway around 180. Pi over 2 is a quarter way around, is 90 degrees, right? Pi over 2 is 90 degrees because pi is 180 degrees. Pi over 4 is 45 degrees. Like if you're somewhat comfortable with some of this in degrees, I'm not saying abandon that. Like you could say to yourself, oh, this is like 45 degrees. So what's cosine of 45 degrees? Well, picture on the unit circle. Because I didn't think they were ready enough. So they said, let's talk about Paystock. Our board members are noticing the dwelling project, and they already have a relationship with Adam. So they're good friends with his sister, Molly, the curator in Milwaukee, grew up with his sister, who's doing a lot of youth of color work in the Midwest. And so she said she was already on the runway to try to make things happen to Adam, and her board members are saying, let's get that piece from Portland and get it to Milwaukee, even if it's not heavily Dakota. Okay. Oh, and pardon me for wait, excuse me for a second. I have an interruption, but that's a unit circle in the background that you could say, you could just picture 45 degrees, the cosine. This is what I'm trying to say, but I'll be back in a sec. Excuse me for a second.
for another reason. Like, she doesn't assume it would have the same level of participation as before. But I said she should at least have a conversation with you just so. Right, right.
Okay. Sorry. Oh. 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 Okay, I'm looking. Sorry, I wasn't. Yes, I see. Right. No, this is good. All right. First of all, yes, everything that what people are saying in the chat is correct. It's not incorrect. It's correct. Right. So you're in degree mode. Okay, that makes total sense. Fine, and that is an LOL. And by the way, if we do it this way, like and it's on an exam or it was real life, by the time if we do it this way, it would be like 1 point off for if that thing was wrong just for being in degree mode, because everything else would be right up until that point. But anyway, yeah, and yes, it's in meters, right? Okay, so this is good. So I think people understand. Yay. And just to finish I was trying to say here, you can think of pi over 4 as 45 degrees in your mind, if that helps, or even you can just say, really the same thing. Like no, actually, I don't have, yeah. So you can think of it any of these ways. And then, so yes, what you're all saying in the chat is right. But then if you plug in just to finish it so everybody can see. Right, so if we finish it, we get.
Yeah, explain to Tanya because I think she hasn't had as many glimpses of what we could do with the content.
Okay, so what now? So I think everybody got it, and I think that's good, and we're going to move on. But just one little note, like it's convenient once you get used to some of these angles or the unit circle or whatever. Yeah, the cosine of pi over 4, that is something I do carry in my head. Like I do know, or I mean, I think of the unit circle and I think I'm in that spot on the unit circle. And I think the y coordinate and the x coordinate are both radical 2 over 2. Like I'm thinking of right triangles and all that. We'll go back over that if we have to. But so yes, the cosine of pi over 4 is radical 2 over 2. So the 2's beautifully cancel and you get as an answer x equals radical 2. But then this does raise a question, like this actually came up in a totally different question in another class. Like say this were an exam or super high stakes or a magazine, publishing an article in a magazine, or say we weren't in a virus and we were like in an actual classroom talking like human beings. And we really wanted to know, like, wait, so we get radical 2, we get root 2. In a math class, they always have us keep it that way. And for good reason. In a math class, yeah, the answer would be root 2, radical square root of 2. In a physics class, it's actually not the way we leave the answer, and I'm just saying this, no one said anything in this class. I'm not saying anybody was wrong, but just so everybody knows, actually how we would mark our final answer here, or our answer if we're going to use it for other stuff, we would change it to its approximate value, and we would chop off digits. Like we all know, we are chopping off digits here. We are, but we're acknowledging that by saying it's an approximate equal sign. In physics, we would rather have, in physics, just to be clear, like we would rather take 1.41 and know that we're missing digits, and even say on an exam, even know that maybe someone's even being sloppy with significant digits, maybe they even give one more than they should or something. Still, we'd rather have that, and a number that we could, written as a number that we can picture, as a number that we could find on a meter stick. Like I could imagine finding 1.41 somewhere on a meter stick, like between 1.40 and 1.42 or something, if the meter stick were long enough. I could find a 1.41 on a meter stick, but I could never find a square root of 2 on a meter stick. I could never see square root of 2 in the lab or in space and time. I could never get data that would suggest square root of 2. So in physics, we'd always rather something that seems real and concrete and measurable and workable than something that seems exact. That's just the way. So we don't write square root of 2, we write 1.4. All right, but I think that's very good. I'm gonna, what time is it? Okay, I'm going to do one more question like this. Again, the same rules, like we just keep going until we get a right answer. But at any time anybody wants to ask any question, please do. I mean, I'm just doing this to fill time, sort of, not to fill time, but if you have a question, stop me and I will answer it. But other than that, we're just going to keep going like this. So here's question 3. So I'm looking at the chat. Okay. But I think we're already covering a lot more ground than we did the last couple weeks just for doing it this way, I think. Who knows?
But then what is going to be needed or need to get the other content from Adam and Tiffany into focus?
Oh, sorry. Okay, please do these three, and I'm gonna pause for a second, but these, again, the first two might just be plug-in, or they might just be plug-in, but just see if the answers make sense to you or not. But let's try to get all three before there's discussion or anything like that. So it's these three. They're just trying to practice, but also I'll be right back.
Professor, we can hear you.
Yeah, no, we can't hear you. I think you're muted.
So wait, no, it's not. Sorry, wait, can you hear me now? Sorry.
Now we can hear you.
Okay, sorry, thank you. So I totally did not. Yes, I was muted. I totally didn't realize that. Yes, no, I'm excited. You guys, I'm saying A, B, and C, your answers are correct. Like the answers of, and it's great. It was great to watch actually, because first you were somewhere. This is what I was saying a second. First you were somewhere, and then you were somewhere else, and then you were at the right answer. Like you guys worked your way to it, and which shows it wasn't obvious from the start. Like, you know, there's a reason to be in class or whatever, but you got it. Yes, the answers are +2, -2, or am I saying it backwards? Sorry, I just forgot what the yeah, the answers are +2, -2, and then this weird like 1.93 thing. I will write them out in a second, perhaps. But if you're starting to get used to, but I'm saying more and more people are clearly saying more and more right answers and seeing where they're wrong. And all these answers are in meters. But if you step back and look at it, like you might have plugged in the equations, but you might also just note the period of this thing is 8 seconds. So for part A, where it says, where is the mass at t equals 16 seconds? Well, if it goes there and back in 8 seconds, then in the next 8 seconds, it's going to go there and back again. So in 16 seconds, that's like 2 periods. It's right where it started the whole time. It does make sense, in other words. Then 20 seconds, it's gone like there, back, and now just there, like half a period. Like it's like 2 periods and a half. So it's at -2 seconds, like -2 meters. All this, I'm sure. I'm not saying you can't plug into the cosine, like so here. Right. What we're partly trying to show here, I know we're doing the same exercise over and over again, but if you start looking at the answers, they start to form a pattern and show something that makes sense. We're trying to sort of physically show what the cosine means, or we're trying to mathematically we're either trying to teach that, I'm trying to show that the cosine really does mean something physically. And that is this, like you get to this, if you're just plugging in the numbers, you get to this step where it says x equals 2 cosine of 4 pi. Well, you can plug that into your calculator and ask your calculator, what is the cosine of 4 pi radians? But if you just think about the unit circle or think about what that means, 4 pi is the same thing as 2 pi, which is the same thing as 0 pi, right? It means go around fully twice. That's what 4 pi means. Go around fully twice. So you end up where you start. It's exactly equivalent. In other words, the cosine of 4 pi had better be the same as the cosine of +1. You're going to be at that same place. I don't mean of +1. I mean of 0. You're going to be at that same place in the unit circle. If you plug it into your calculator, you will get that the cosine is positive. I keep doing that. That the cosine is +1. In other words, the cosine. Sorry, yeah.
Can you let Ariel back into the
Sorry, yeah.
Zoom meeting? Her internet's being weird.
Sure, but I don't actually. Oh, I see. Yes, I'm sorry. Yes. Wait. No. This is the priority. Okay. Yeah. Thank you. Sorry. Yes. I think it just worked. Okay. So whether you just think about it in your mind as cycles, or you do the cosine and think of unit circles, you're getting the same kind of repeated answer. It's trying to show that's why cosine is the mathematical function that describes these cyclical oscillators. Okay, so x equals +2 for that one. I'm just quickly saying, and then for B, same thing. But now it was 20 seconds, right? I think.
Dad, I really need to join you now.
Wait, okay, hold on a second. Okay, just 1 second. And again, here, you can plug this in, pardon me for 1 second. So again, here, you can plug 5 pi now into the calculator and and make sure you're in radian mode and take the cosine, or you can think 5 pi, what does it mean? Well, it's 2 pi means going all the way around, like 1 pi means going over there. I'm always assuming, I'm always picturing the unit circle, right? I'm always picturing that what all these sines and cosines mean is that we're sitting on a circle centered on the origin, radius 1, right? And this is like one of those many tools that you hate it until you love it. And I love the unit circle, and I didn't when the first 400 times they showed it to me. But what we're saying, just always picture that angles open up from the positive horizontal axis. The angles are measured in here. And this is a radius 1 circle. So these coordinates are 0, -1, this is 0, +1, this is -1, 0, this is +1, 0. And whenever we're asking cosine and sine, we're just asking, what are the horizontal and vertical coordinates of a point of intersection between that angle and the circle? So one touch lower, please, just one. So I'm saying when I have the cosine of 5 pi, I could plug it in, thank you very much. I could put it in the calculator, or I could change 5 pi in my mind to 900 degrees, which is right. Or I could just picture, what does 5 pi mean? It means I go around the whole thing, which is like doing nothing at all. I go around the whole thing again, which is like doing nothing at all. So now I'm at 4 pi. And now I go 1 more pi to the other side, to where the cosine spits out a -1. Like the cosine of 5 pi is -1. X here would equal 2 times -1, as it should, because 5 pi means go 2 full cycles and then go a half a cycle to the other side of the oscillator. All right, so X equals, so I totally agree. I shouldn't be, but you all got this, so I shouldn't be over explaining it. And then C, I don't even remember what I had. Oh yeah, and then C is also plug in. And the pi's cancel and C. And so we have 2 cosine of 1/4, and that doesn't say pi over 4. That says 1/4 radians, like 0.25, and that's not. And a radian, is about 57 degrees. So this is going to be the cosine of about 14 degrees. But that's not some natural, elegant angle or something. That's something I totally would do on my calculator. The cosine of 0.25 is not something I carry around in my head. It just is what it is. It's like 0.969 or something. So then I multiply that by 2, and that's where we got Ariel's or someone's answer of approximately 1.93. You could put 0.193, or 0.194, it doesn't matter. But that's where that answer came from. It's approximate. Oh, but notice one thing. So that's the answer to that one, and it's good. And I think people are doing well. Notice what I like too is people had the guts to put in some answers in the chat. I don't know exactly what they were thinking. They were thinking something logical. But what I was able to say at the beginning was, okay, we're not quite there. These aren't the right answers yet. Because I knew in advance, I'm picturing this thing, just trying to picture the whole thing. We've got an oscillator that's, its amplitude is 2 meters. That means it's both its initial, wait, 1 second. One second. It's an initial position and its maximum position. So this thing is oscillating between 2 and -2. So any answer beyond 2 signals something's wrong. And you just want to get in the habit of just try to plug in and stuff, but while you're going, just keep checking with your intuition about whether the whole thing makes sense. I'm going to give you what we may end early today, actually, because we are kind of rocking this. I think I'm going to give you one more, but I'm going to give you one more right now to work on. I'm going to be even quieter this time. I'm also going to deal with something in the background. So hang on, but here we go. This is slightly harder now. but still plugging in the same kind of things. No new equations or anything like that.
Is there anything realistic that we can, because like where I compare that page, I don't have the big access. I got some from the opening credit, but I just feel like I could see into it. That was what I thought. Right.
Okay, the next question, again, just building from the same, I'm going to explain it and I'm going to shut up. Same situation, mass on a spring, going back and forth, same amplitude, like same maximum stretch of 2 meters from equilibrium. Okay, same deal, no tricks. Same deal, it takes 8 seconds to complete a cycle, which means equivalently that it's omega, it is, we found out before, is like pi over 4, I believe, radians per second. Same thing, however you want to say that. Again, that's the Vicky thing, they're one and the same information. All that's still true, but now I'm going to add one hook, one new hook, so to speak, which is, now imagine though, and there's a reason for doing this. This is not just to be annoying. Imagine now, however, that even though the amplitude is 2, like even though this thing is swinging back and forth between 2 and -2, imagine that we start timing not at 2. Like imagine that 2 is not the initial position in effect. Imagine that we start our stopwatch at some point when this thing is at equilibrium, at x equals 0. For some reason, we wait until the thing is at equilibrium, then we start our stopwatch. So in other words, at t equals 0, the thing is not at 2. Imagine that at t equals 0. So in other words, at t equals 0, imagine that in fact, x equals 0 as a not positive 2. Slight change in the experimental setup. Given that, I ask the same question, like again, at 1 second from there, at t equals 1, then what will x be? Okay, you can use the equation, you cannot use the equation, do whatever. I'll stop you once I see a right answer, or I'm going to retract my, oh, is that a thought? I'm going to remove myself for like 5 minutes, so you might get the answer faster than I notice, and if that's true, I apologize in advance. But yeah, we're looking for a right answer to this. Same situation, same question, only difference is we start timing not from the amplitude position, but from the equilibrium position. Okay. Okay, I don't know if people can hear me or not, and I don't think this is easy, but hopefully people, and you know, the more like the whole, if we were all together right now, this would be like something we would call a board meeting. Like the more I can reduce any large physics question to smaller and smaller pieces, so it's down to just like little things that you literally can picture and either go, yes, I agree with that, or no, I agree with that, the better we're all doing. But the more it might seem like we're not accomplishing anything. What I'm saying here is you guys are all, you're getting there, I think, with your numbers. But one thing that's sort of interesting about all these numbers that I'm getting in the chat, and they're not, I know they're not random guesses. I can recognize most of these numbers and understand that you're doing something. But one thing is that but something is wrong because all of these numbers that are being guessed are positive, and there's no guarantee. I have no reason to assume that they would necessarily, it'd be a positive answer. In fact, I guess what I'm hinting at, looks like someone has a thought. Okay, I'm gonna be quiet for a second. Hmm. No, well, I don't know why that would be okay. Zero can either be a frowny face or a smiley face. It can be very exciting and rewarding when we get zero. Right, but I don't think it is zero. It's true. I don't agree. Or let me ask everybody. Wait, but if nothing else, again, let me say, and I know the more it seems like we're getting wrong answers, the more time anybody says an answer that I say is wrong, or the more it feels like we haven't gone forward, the more to everybody could feel like nothing is happening here. But honestly, I think mentally for all of you, or intellectually, I think more is happening right now than has happened in a lot of classes. Like if you're all don't see the answer, what's very convincing to me more and more is that all of you are looking at the same question I am. Like we're all worried about the same thing, which is important and which is what it takes. So we are progressing here. Oh, I'm looking at the chat. All right. Oh, and I see, now you're really taking me seriously. Okay, the last thing in the chat. So people are really seriously trying to take the strategy that I'm saying or that I wrote in the chat. But now I see it is such a subtle thing. I see where there's now a very subtle misunderstanding that's going on. So I'm going to try to help out now. And we will wrap up when we get this. What's given is everything written on the page here. Oh, and by the way, and again, if we keep doing it this way, where I'm just like going to wait until we get right answers, but I'm giving points to people for saying anything, I promise you all, and this is kind of a small class, but if this works, the more this works, the more we're going to do it and the more I'm going to gamify it. Like I will make more and more complex point structures so that if someone's saying like 50 things in a class, they'll get like a lot of points. I mean, I do want to reward everybody amply. Like right now, I am saying like the most you could be rewarded for anything you said was twice today, but a lot of you will be twice. Like a lot of you have already said things that you should submit twice for 2 independent things of 50 extra points. But now what's happening here with the physics, I'm saying the givens are still the givens, but then I'm recommending picturing in your mind, okay, since capital T equals 8, like since I'm not changing that fact, since this fact is still this fact, the period is still 8 seconds, then I'm asking you to picture what would go on in. Let me back up for a second. I think one thing that's confusing people in the back of their minds without realizing it is, don't use lowercase t and capital T, even in your minds, interchangeably. In other words, the period, capital T, is 8 seconds. So that means it takes 8 seconds to do a full round trip from wherever this thing starts. Like wherever you're measuring from, it's going to take 8 seconds to get there and back. So if we start measuring when this thing is in the center, it will take 8 seconds to get like there and back. Like just like if we measured it from the end, it would take 8 seconds to go there and back. This is like the graphs you were watching in videos or whatever yesterday. But if something's starting in the middle, it's going to take 8 seconds to go there and back. So in 8 seconds, it'll be back where it started. It'll be at x equals 0. I'm not asking 8 seconds. I'm asking 1 second. So one way we could think about this is, let's picture what would happen in 4 seconds. Now, here's where a subtle error happened in the chat. I don't know if I'm going to give away the answer or not, but like when I said now picture 4 seconds, I don't mean to anybody picture changing capital T to 4. I'm not saying that. I'm not saying let's pretend instead that capital T is 4. No, I'm still holding capital T as 8 in my mind. But I'm saying run lowercase t to 4 in your mind. Like, given that capital T is 8, given that the period of this entire thing is 8 seconds, if you let 4 seconds elapse, where would you expect to find this thing, is what I'm asking us to do. Again, picture if the mass started all the way on one end, if it didn't start in the middle, if it takes 8 seconds to go there and back, then it would take 4 seconds to just go there, right? Like, in other words, this mass here that's starting at the center, if I let it go for 4 seconds, I don't think it's going to go there and back. I think it's going to go there, right? Like 4 seconds, it's going to go halfway on its journey. It's just going to go, like to where it is, not the full round trip. Put better, in 2 seconds, where's this thing going to go? In 2 seconds, I think this thing is going to go from where it is in the center to the end. And that's it, right? Like, I think the math will prove that, but I don't think I have to do the math to see that if I'm understanding how this math is working. If it takes 8 seconds to go all the way there and back to where it is, if it takes 8 seconds to do a full cycle, in 2 seconds, it would do a quarter cycle, right? So just like something that on an end, in 2 seconds, we get from the end to the center, right? Because in 4 seconds, it would get to the other end. In 8 seconds, it would get to the other end and back. This thing, which is already in the center, in 2 seconds would get to the end, I think, right? And so in 1 second would be somewhere between where it is and the end. It would be in the negative lands, I think. So I think the correction I'm making to the chat is I'm not changing capital T to 4. Like, she's right. Like, Vicky's totally right. If I change capital T to 4, then omega does change to pi over 2. That's why, so everything she's saying is totally logically self-consistent, and other people are doing things like that too. But I'm not trying to suggest changing the capital T to 4. I'm saying, given that capital T is 8, then what does it mean if we, in other words, if the whole cycle takes 8 seconds, then where will this thing be in 1 second? It will be an eighth of its cycle. Right, an eighth of its cycle, only measured from where it is, not measured from the end. I don't know if I'm. So I don't think we have the right answer yet, I guess is what I'm saying. But and I see the time. Like, technically. So look, again, this is the last thing we're going to do today, but it'll help us get to waves, which is where we're trying to go with all this. But I'm just trying to say, look, back up. If this mass had started, we did the other problem, like if this was just a normal problem where we're starting our stopwatch at the amplitude position at 2, when the mass reaches its end point, its farthest displacement from equilibrium. If we start our stopwatch then, what we know is it takes 8 full seconds to go all the way there and all the way back. So if we know that, even without the equations or anything, what the equations are trying to show is that, okay, in half a cycle, in 4 seconds, it would just do a half a cycle, it would go there. And that's what this diagram is sort of trying to show. In a half, like it says half cycle in yellow, it would get to that star. In a quarter of a cycle, it would get to the 0. In an eighth of a cycle, it would get midway between the 0 and the 2. It would get to the 1 position. Like and the same thing is happening to us here, only we want to shift our entire reasoning, our entire perspective, the same logic, just break down the trip. But imagine I think I'm not going to cross. I think the answer is negative. I think the answer is negative square root of 2. It's like the same answer we got for the very first question, but it's negative. It's negative 1.414. I know we all have to go. Like what I'm saying is, I think this thing will have traveled a little bit to the left. Like if it's starting at 0, if we gave it 8 seconds, it would go to the left, right, and back. If we gave it 4 seconds, it would go there, but not back. If we gave it 2 seconds, it would make it to the end, to -2. If we only give it 1 second, it's just going to go a little bit between 0 and -2. How little bit? I think the same little bit as we said before, like square root of 2 little bit, like it's going to be around -1.4. Maybe you don't see that immediately why it'd be 1.4, why the same answer as before. I'm saying it's because we're just shifting the whole problem. But I am saying what I want everybody to see, at least for the moment, is the answer to this question has to be like a negative number between 0 and 2, because the thing has barely had any time to go anywhere. It hasn't even had enough time to go all the way to -2, let alone back into the positives. Now, how do I exactly get this answer? And this is the last thing I'm going to say today, and we'll just go. But I think you guys did I think this last question was harder. I think, as usual, it's like 2.5 hours. It's too much for everybody. But I think people are doing, I appreciate how you're doing with this format. Please remember, anything you said today, submit it in that homework thing. And especially if you said something subject to right or wrong, then submit it twice. You'll get many points. I'll just end with this. Okay, so again, I'm saying that, again, just to be clear, the answer to the other question was 1.4. Negative 1.4. I was sort of trying to show how you could picture it, or at least how you could think about how some other answers might not be right. But I didn't show you yet the most direct or fastest way to actually get the exact answer. And I can't expect that anybody would have had the fastest or most direct way to get the answer. But I want to give you an equation now. This is the last thing. I'm going to give you an equation now, which will help with this kind of question in the future. We didn't need it to answer this, but it'll help. But this equation that I'm going to give you now would have no context. You'd have no need for it or no understanding if we hadn't just asked the question we did. In other words, from now on, if you have an oscillator that does all the things we're saying, that goes back and forth at a constant rate, but if for some reason, and there is a reason that sometimes this happens, if for some reason the oscillator does not begin at its amplitude position, or for some reason, put another way, you don't start timing at what we would consider to be the natural beginning point of the cycle. If you start timing somewhere else in the cycle, like halfway through the cycle, or a quarter of the way into the cycle, or a quarter of the way back into the last cycle, if you start timing anywhere else in the cycle besides at maximum displacement, one way that can be captured, and this is just what I'm going to say, we're just going to end with this, is you can say, sorry, one second. So this is, again, this is a new piece of information. Now we're going to end with this information. I'm saying that an oscillator can start somewhere other than the 0 point of a cycle. It could start with a head start, like it could start already being at the equilibrium position. We would consider that a head start of a quarter of a cycle, because remember, a cycle is there and back. So if something started, say, there, that would be a head start of a half a cycle. Like, I mean, if it started at -2 instead of 2, we would consider that a half cycle head start in the cycle. And what is a half cycle? It's pi radians. So we can add that in, that term. We can put a term here in the cosine parentheses, a term measured in radians, as it says here. And what that term represents is what portion of the cycle you started ahead of the clock or behind the clock. It's called the phase constant. And so, for example, in the one that we're doing today, if something started at the equilibrium position rather than at amplitude at x equals 2, we would consider that a head start of a quarter of a cycle, again, because like halfway the cycle would be all the way from 2 to -2. So a quarter of the cycle is from 2 to the middle. A quarter of a cycle is pi over 2 radians. And we could capture that in this term right here in the parentheses called a phase constant. Last page. Oh. Oh, yes, Vicky, you got it. Sorry, but yeah, yes, essentially, yes. You get what I'm saying. I think I'm like 20 minutes late on that, but this is where I'm going to end right now. I think technically, like, we're done in 7 minutes. I didn't give anybody a break or anything. Again, I think we're making progress. I really appreciate everybody who has said anything. I think I've made that point. I'm going to go. Thank you all very much. I will see you next week.